Hello, everybody. Today we have Mr. Yashas Karanam. He is COO and co-founder Bellatrix Aerospace. As you might be aware, it's a space tech startup, which is an upcoming arena in the startup sector in India. Hi, and welcome to Business World.
Hi, Urvi. Thanks for taking me on this call.
Right. So let's just start off by knowing more about Bellatrix. What does it do, and how did you land up starting this company?
Yeah. Bellatrix is a space transportation company where we help satellites move between orbits. Just like we have cars here to move from one place to another, we provide engines which help satellites to move in space. So the job of a rocket is only to take a satellite to a particular orbit called a parking orbit. You go from ground to there, and then you ensure that your satellite does not fall back onto the earth. You provide the required escape velocity. So once a satellite has reached this parking orbit, it needs to go to its exact destination for which it has got the licenses, approvals, and where it is supposed to operate. So that job is done by engines which are mounted on the satellite. That is one job where a satellite propulsion system comes in. And once a satellite is in orbit, it needs to maintain the exact orbit orientation for a long period of time, so its entire lifetime. That's again where a satellite propulsion system comes in. So if there are some deviations, so we fire our engines and get them back in the right orientation. And finally, at the end of the life, you need to deorbit your satellite and clear that orbit for a new satellite to come in. So that's also where a propulsion system acts and brings that satellite down to the Earth's atmosphere or moves it to something we call as graveyard orbit. And we build such satellite propulsion systems or engines. And one of the unique thing at Bellatrix is that we build highly innovative technology. So we are trying to build the most cutting edge propulsion technologies out there. So end of the day, the goal is to kind of reduce the cost of access to space with these newer technologies. And for the customer, we look at how we can save cost for the customer, not just when they're buying a propulsion system, but over the entire span of 10-15 years when they're using. So that's what Bellatrix is up to.
Right. That sounds really interesting and right out of a sci-fi movie. So I wanted to ask you that given that space tech is a relatively new space as compared to all the other domains of, say, edtech or fintech in general, what are the challenges that you faced to establish your company, and how were you able to overcome them?
In fact, we were one of the oldest space tech companies out there. So we started in 2015 officially, but unofficially we were this bunch of guys in college. So we started this in college. So we were in college and we wanted to build a space company since about 2012. So we started out with a new innovative kind of propulsion system as a college project. Probably something that can fetch admission into a good university in the US later and then again come back to India. That was the plan. But later we realized that we had some demonstrated capability in building efficient propulsion systems that are probably class leading in the industry. So that is when we decided, why not we take a plunge into entrepreneurship. We knew the space tech was tough and probably we were the crazy guys who wanted to do it, whereas everybody wanted to get to a normal job or maybe a IT job or a mechanical job. That has always been the core in India. So we still decided to take that plunge and start a space tech company and face whatever odds that may come in. But I think, fortunately for us, I think we have gone through several bad tides and good tides, and today we are in a very good position. And space tech is also opening up in the country, and there is now a lot of potential for new space companies to come in. But when we started, things were much different. So we were among the very like 2-3 space companies out there in the market, and space industry is like a sinkhole for money. So more capital you put into the industry, you can develop more, build better products. So at such a state, we did find it tough to kind of find investment, and that is where I think ISRO kind of helped us. We got a first of its kind contract from ISRO at that point of time in 2016, just 1 year after we started the company. And with the help of that, we started also learning from ISRO on how they qualify their propulsion technologies, what really goes into the qualification standards that ISRO requires. So we were also one of the first company in the entire country to get such a contract from ISRO, where a complete system was developed by a third party and given to ISRO. Normally, you know how ISRO works is they develop the technology and do a technology transfer to a manufacturing company and get it manufactured there. This was like first time where they bought a complete complex system like a propulsion system from a third party company. So with the help of that, I think next 2-3 years went into building a strong team, understanding how to build these propulsion systems for ISRO. So that went on, and eventually only in 2019 were we able to crack in some investment. And we were also very serious at that point of time that it is not just India. There is a large global outlook and a global market opportunity out there. So we decided to take in some private equity and make Bellatrix a global player. So we started out with funding them. And from a tech side also, we faced many challenges in terms of the fact that outside ISRO, there was no other agency or body or university which worked on propulsion systems. So only after we got in did we realize that we have put our hands into something that probably an entire country does not have expertise in. So we could not get any experts, any professors or any people in the industry who know this. So we had to do things firsthand. So it was like a college project, but 100 times tougher than a college project. So it has been a lonely journey, but I think today we are at that point where all these developmental cycles are complete and we are about to hit commercialization.
All right, that's really good to hear. Quite a fascinating and gutsy journey you had to venture out into a space that was not explored before, literally.
Yeah,
So,
but I think we have to really give it to the team who really made that possible, right? So we have some of the best engineers in the country working with us. Really, thanks to them that this is possible in the country.
right, that's really heartening to see that people are taking the space tech domain so seriously. So, moving ahead, I also wanted to ask you that the Indian government has introduced privatization in the space tech sector last year itself in 2020.
Yeah.
How has that impacted Bellatrix, and where are we still lacking? What else should the government do to promote startups like yours?
I think this is definitely a welcome move from all space tech companies in the country, because till that point we really did not have any clarity on whether a company like us or probably a company like Agnikul, Skyroot or Pixel, who are currently out there in the market, whether we all could exist, right? Whether an Indian company can build its own satellite and launch it to space on maybe an Indian rocket or a foreign rocket, whether that is permitted or not. Today we probably spend some $10 million in building a first class satellite. Tomorrow we launch it, and if there is a notice that is coming to us saying that it was not legal, there was no rules to launch your own satellite, then we are making a 10 million a 10 million crime, right? So that is something that was very unclear. It's only with the space policy that the government opened up last year that now companies are authorized to do it. So we are officially allowed to build our own satellites like ISRO is doing it. We are officially allowed to build our own rockets like ISRO is doing it. So this is something in the making. So I think now it is important that the government also keeps this on priority and does this very quickly and moves this policy through the parliament and gets it done as an act. So right now a draft has come out, but the actual act has still not come out. So if that comes in very quickly, that will surely help us. And secondly, this is a very capital intensive industry. So if you look at how NASA, ESA and all these other space agencies work, they all, apart from promoting their companies to do it, maybe not just by allowing this through regulation, they also help in certain critical tech transfers, and sometimes they also like give very big contracts, grants to private companies. That is also a very successful model in the West. So I think we should also try to pick up what is good and what has worked there and try to incorporate that in the country. Because at the moment still there are in India, if you look at the ecosystem how it is, there are very big companies which have bulk manufacturing capabilities who can probably manufacture 100,000 units of subsystems for ISRO and DRDO, but they cannot independently develop their own technologies. So they may be manufacturing a particular product, but if you ask them to change certain parameters and build a newer, better product, at least at the moment they are still picking up, and slowly that capability is coming up. Maybe in 5-10 years that could change and they will be able to do it, but right now we are still not there. And from startup side of things, there are probably a handful of startups, maybe 10 plus startups in the space sector in India, and all of us require funding, and we still have quite a journey to get through before we are successful, right? So you look at all the accomplishments that ISRO has done. For private industry to pick up and even be somewhat probably 20% of what ISRO has done, it still takes time and effort, and somebody has to push and help us through the policies, regulations, funding, all these valleys of debt. So I think we need an enabling ecosystem that probably through the government and through ISRO pushes and helps companies to get.
And what about individual initiatives like, say, in space, or giving the right of technology to the startups so that ISRO can focus on larger issues? How is that working out in the startup ecosystem space?
This is something that needs to completely come into practice. So right now, ISRO has, I think, fortunately started communications, and we are already starting to interact. Even Bellatrix is interacting with space for that matter. So other companies have also signed NDAs, and some work has started. But definitely we will know more once the Space Act comes into picture, once the Parliament passes it and this in-space body is institutionalized as an independent body and starts work. So this is definitely a very good move, and I'm sure, I think probably by 5 years we are going to see the benefits of this coming. Definitely a good thing.
Right. When we talk about any industry, any upcoming industry rather, it always gives rise to more kind of industries. For instance, if we are talking about space tech, it will also generate employment in the technical sector, for example,
Right.
or the engineering expert that you have on board. What is your prediction about the collaborative businesses that are going to come up with the space tech startup space?
I think that's a very good question. So if you looked at the word software, that kind of is the biggest industry in India right now. The word software was coined as part of the Apollo mission, where software was first developed as part of the crew mission, where astronauts had to be sent to the moon, right? So that spun off, and it became a very big, huge software industry that impacts every one of our lives, and today we can't live without software. So similarly, space tech industry has given several things that have helped various other sectors. For example, new materials were developed by NASA, which got incorporated in almost every other industry. New alloys for the space tech, which got into maybe the flights and automobiles. So a lot of industries took up from there. And similarly, even today, there is a lot of potential that is coming up in the space industry. So going forward, all the companies, space agencies, and all the industry players, we are all looking at a future space economy. What it means is probably there will be manufacturing that is happening in space. Satellites may not be built on Earth, but there could be satellites built in space and directly deployed in space. And then there can be cargo that is moving to the moon and coming back. When you probably, if you don't have anything much on Earth to mine, probably people are going to start mining the moon and stuff like that. So when such things start happening, though I don't want to sound like somebody too greedy, but I'm just saying that probably we save Earth and start looking at something else, right? If we really need it. So at such points of time, I think there is a lot that space industry has to still go through in terms of developing new technologies. And I'm very sure that a lot of those are going to translate into the Earth and see a lot of applications here. So a lot more to come.
Your ideas of mining the moon and manufacturing satellites in space itself are really very futuristic. I, as a non-space tech person, have probably never thought about these possibilities.
I think you should also closely follow Elon Musk, who is probably putting his own money into building a colony on the Mars.
Of course, we've all heard about that, but these are different takes on it, I would say. I never really thought about mining and manufacturing, or a lot of our viewers probably also did not. So,
in fact, you should also see the NASA's recent initiative. So all their funding is going into a program called Artemis.
Yes.
So it's a new code name for going back to the moon and doing something on the moon. So it has something to do with all this mining, setting up colonies, and at least people should constantly go back to the moon. So there are definitely grand plans for this.
Right. I hope that we see an Artemis or the like coming from your end as well very soon, given that you're the oldest.
One of our first step in that direction is something called an orbital transportation vehicle. It is basically like a taxi in space, which is going to carry multiple satellites and deploy them in multiple satellites, and then end of the life have certain hosted payloads and be in orbit for certain periods of time. That is probably the first step in that direction, and probably once that is successful and commercial, probably in 2023, and then we are not turning back. So we are looking at many more applications that are going to be cutting edge and disruptive in space.
Okay, can you tell us some applications that you're working on, and any new technology that is being developed by Bellatrix and which will also be seen, say, by ISRO or NASA?
So something we just announced last month, we unveiled a new product called the Hall Thruster. This is again a very efficient form of electric propulsion system, a kind of propulsion system that helps satellites move in space. And we were the India's first private company to do it. So ISRO has been also developing this, but outside ISRO, we have been the first Indian private company to do this. And also, that is one of the product, and the reason I kind of highlight on that is it is kind of the product of the future. So if you look at all the satellites that are going to go up, so there will be several thousand satellites that will be launched. And if you look at the size and mass class of these kind of satellites, our Hall Thruster would be an ideal choice because it packs in the right amount of performance at the right amount of power. So it's like a very ideal fit. That is one of the product that we have built. And another interesting product that we have already delivered to ISRO, and we have a long heritage. So our first product, it's called the microwave plasma thruster. It's a very unique kind of electric propulsion system. We even now recently got a patent in the US for this, US India. Right? And this uses water as propellant. So unlike all other propulsion systems which uses various other kind of sophisticated fuels and chemicals, it uses the simple drinking water as fuel, and it is extremely efficient, long life. So it comes with a pack of advantages. That is what also it kind of interested ISRO, and some of our global clients are already quite excited to have this. And we also have developed one of the world's smallest propulsion system for a nano class of satellite. Maybe if you're talking about student sats. So we have one of the smallest kind of propulsion system in the world. And lastly, we also have another product called green propulsion. So conventionally, there is a fuel which is called hydrazine, which is used in most of the satellites. And hydrazine is extremely toxic and carcinogenic. People have died while making hydrazine. And if you need to go into a manufacturing plant where hydrazine is being manufactured, you need to wear suits called CAPE suits. And these suits also carry oxygen cylinders because you can't even inhale the fumes even a bit, even in small quantities. So it is that dangerous. So we have come up with a very greener alternative, which is very safe, easier to handle, and it is also very cost effective and much better in terms of performance. So from satellite propulsion side, we are a full suite solution provider, as we call it. So you come to us with the smallest satellite out there in the market or the largest one. We have one unique indigenously developed solution that can fit into it. And the next logical step, as I was saying, is this orbital transportation vehicle, which will help satellites move to different orbits and deliver customer satellites to their respective orbits, like a Uber pool in space, where you're ride sharing with different people and cutting on the cost. So that is something that we have.
Yeah, the pandemic has dissuaded all of us from taking Uber pool in real life. So why not do it in space now? But coming back to space tech in particular, what do you think is the future of this particular industry, say 5 years down the line, or if we come closer, say 1 year down the line? What do you think is going to happen to this particular industry, and what will be Bellatrix's role in it?
So going forward, I think industry has already come to a certain stage where a lot of things are happening today because the industry has matured to a certain level. Probably if pandemic had happened 10 years back, right, we would not be working from home. Maybe we would have lost jobs and gone home, right? So
Yes.
that infrastructure was never there, and that has happened because of the advancement in satellites today. And if you look at future, a lot more is changing. You have Internet of Things, connected devices, smart homes. Going forward, the companies are going to push for smart devices. You will have smart fans, smart air conditioners, smart refrigerators, all controlled through a smart device. Currently, all the smart devices are in your house, and you're probably controlling them through the mobile. But going forward, there will be micro, small sensors which come with all these appliances that we are working. And probably if you are traveling, there will be micro sensors attached to your cars, and wherever, whatever you're doing, which can be converted into an electronic gadget, that will be done. And all of them are going to be have sensors which are going to start communicating directly with satellites. So there are IoT satellites that are coming up. So with that, what is going to happen? You're going to have a very strong, robust control over everything that is happening. Probably you can start from US and probably book a cab by the time your flight lands. It can actively kind of monitor if there is a delay in your flight and accordingly book a taxi for you, right? So such things are going to be possible, and that is one part of the thing. And second, now demand is actually really increasing because more and more companies have decided to not come back to office again forever, right? So with that, people are moving to remote locations, and still, at least in countries like India, I'm pretty sure there are also a lot of places, even in developed countries, which are not very well connected to the internet. And it's always not economical to lay cables across the entire country, right? If you want to lay down internet cables like fiber cables to the rural parts of India, I'm pretty sure it will take us another 20-25 years to fully afford and get everybody connected with the internet. So one major solution that is coming up is direct to home, that came up and revolutionized the cable industry, television cable industry. Now you have these set-top boxes that are going to directly relay a cable to you. So similarly, from internet side, you are going to have a small box in your house that is going to communicate with the satellite, and you get high-speed internet and a very good phone connection directly from the satellite. You need not get it through ACT internet connection or a Airtel internet connection for that. So these are some of the areas you look at. But long term, as I was saying, there is going to be a space economy, and there will also be a lot of services done in space, and a lot of microgravity experiments that we can't do here on Earth. All those things are going to be done in space. And when you are manufacturing for precision, you need vacuum and zero gravity for certain items. So all those things can be done in space. And if you look at medical industry, there are also multiple interesting applications where people are proposing that organs and tissues can be printed in space atmospheres. They can't be printed easily here, but if you go to space and print them in space, that is still a possibility. So a lot of applications.
Yeah, we already have space diplomacy and space security and guidelines around it coming up. So, space economy seems to be the next intelligent step in that direction. So, since we have a certain paucity of time today and we don't want to stretch the discussion too much, so before I let you go, I wanted to ask you, what would you like to say to upcoming entrepreneurs, specifically in the space tech domain, and what should they be wary about, and what would be your words of wisdom for them?
Well, definitely, I would like to encourage everyone to come and take up space as an industry, because now probably the central government, ISRO, everybody is ready to support you, and it is the right time to get into this industry. Right? So probably if you want to come in after 10 years, there would be a lot of startups in the country, and you might not have a lot of space here. Maybe now is a very good time. But at the same time, in terms of being cautious, I would kind of advise everybody to have a strong technical backing. You should not be creating a space company because you want to become an entrepreneur, right? You need to have certain things that you want to accomplish and a certain problem that you want to solve. And once you have identified that problem, my suggestion is probably talk to 20-30 people and kind of get ascertain that nobody else is building it and whether a customer really wants to buy it. Normally, it so happens in all businesses, especially in industries like space tech, where you don't have access to a lot of information, that you think you're solving a problem, but you may be solving a problem that nobody wants to buy or pay for. right? So you want to get that validated. And lastly, it's a very quality sensitive industry, and you need to have a lot of commitment and grit in overcoming all the technical challenges, because it's a very safeguarded technology. Probably countries worldwide, they don't publish a lot of information because of national security reasons. So if you want to probably build automobile or something, you don't have any new unknowns. So you might have to manufacture a part in a particular way. You need to find a manufacturer, build a mold, get it done, right? It's all known. Here you don't know physics of certain things, how they work. You don't know how space environment treats your material. Probably something is going to work here, and you test it 100,000 times, it works, and it might go to space and still fail. And once you send something to space, it's a very expensive affair. Your rocket cost, which is the launch cost, it costs you probably around 40 lakh rupees per kilogram of mass that you send. So if you send a 20 kg satellite, you can just multiply 20 kg into 40 lakh rupees is just the ride cost to your space. So if something fails, you're losing your entire satellite cost, launch cost. You're burning away several $1 million in a single mission. And you cannot send a mechanic to space and go and repair something that is not working. Right? So you need to be very cautious and technically very strong in whatever you're trying to build. So having a very strong technical background is a must for a space company.
Let's hope we can send a mechanic to space in the near future, and it is a lot more cost effective to do so.
Yeah, maybe a space robot or something.
Let's hope so. So with that positive note, I would like to take your leave for the day. Thank you so much, Yashas, for your valuable insights and making us aware about the possibilities in the space tech domain. Thanks for joining.
You were a nice host.